Okay, then let's have a look at question 8 then. So this is a 6-mark question. Okay, so this is the one time that you really need to focus on your spelling, punctuation and grammar. Okay, so the question is asking, an exploding firework produces sound waves and light waves at the same time. Compare and contrast the properties of sound waves and light waves by describing their similarities and differences. You may use diagrams to support your answer. Okay, so I'm just going to quickly show you part of the mark scheme. Okay, so this is the mark scheme telling you what how you'd score between 1 and 2 marks. So this is a limited description of 1 or 2 differences between sound and light waves. Okay, and an attempt has been made to describe how transverse and longitudinal waves are different, but it may not be accurate. Okay, spelling communicates ideas simply, and SPAG are used with limited accuracy. 3 to 4 marks, a simple description of 2 or more of the differences between sound and light waves, or 1 similarity and 1 difference. Okay, and we're looking for an accurate description between the differences between transverse and longitudinal waves. Okay, and there's going to be some clarity of organisation, correct usage of scientific terminology. And SPAG is used with limited accuracy. Okay, to get 5 to 6 marks, you need a detailed description of both similarities and differences between sound and light waves. But basically, we're looking for more than 2 to get 5 or 6 marks, differences and similarities. An accurate description of the differences between transverse and longitudinal wave, okay, that uses the word oscillation. So we need to make sure that oscillations are used correctly. And the answer communicates coherently using a range of scientific terminology accurately, and SPAG is used with few errors. Okay, so what we need to do then is to write an actual answer. So we need to, let's aim for getting 6 marks. So we're looking for 6 marks, let's be on the safe side, we'll go for 3 similarities and 3 differences. Okay, we need to use the word oscillations. Okay, and we need a good description of the difference between transverse and longitudinal waves. Okay, so similarities. Okay, it's fine to use kind of headings. Okay, both transfer energy and information, but not matter. Okay, both are propagations. Okay, so to propagate means to get something going, to start something off. Propagations of a disturbance. Okay, all right, we're stretching a point here, but both can be sensed by humans and other animals. Okay, so those are some similarities. All right, differences. Okay, so we're looking for at least 3 differences. The first thing you need to say is that sound waves are longitudinal. Okay, but that's not enough to get us full marks. We need to explain what that means. Okay, so which means that the oscillations, okay, are parallel to or in the same direction, okay, meaning the same sort of thing really, as the wave is travelling. Okay. So sound waves, so we can show that with a diagram. Okay, we could show that the oscillations move from left to right. Okay, and the wave is moving direction of wave. Okay, and we could represent that by sort of sound waves. All right, looking like that. So the oscillations are moving backwards and forwards, and the direction of the wave is in that direction. Okay, light waves are transverse. Okay, the direction or the oscillations are at right angles to the direction of the wave, or the direction the wave is travelling in. Okay. All right, so that's one major difference, and we've explained it in some detail. Okay, what else could we say? We could say that sound waves are mechanical waves. So they need a medium to travel in. Okay, light waves are electromagnetic. And can travel in a vacuum. Okay. You could also, all right, that's going to give us plenty of differences there, okay, to get us the full 6 marks. You could also say that light waves travel much more quickly than sound waves. Okay, you could say that light waves travel at 300 million meters per second in a vacuum, whereas sound waves are only traveling at about 330 meters per second in air. Sound can travel through some objects that light can't travel through. Sound is produced by vibrating objects. If you have a look at the mark scheme, which is on the same page as these videos, all right, you should be able to find lots more differences. Okay, but those are the key ones that are going to get you that 6 marks.